work through this old exam question about free fall motion or projectile motion. You need to first try it yourself. Download the question from the link below. And don't forget, while you're at it, to like and subscribe and visit my website, www.learnscience.co.za. Now we're asked questions about this graph, which has to do with the motion of stone A and stone B. Let's first make sense of what we're seeing here before we get to the questions. It's a position time graph. And the thing that you really need to be careful about here is not to give a position when time is asked and vice versa. So let's first just look at a very basic explanation of what's going on with stone A's motion and then stone B's motion. Here we can see that stone A is launched upward. This is the height, 40 meters above the ground, at which it's launched up, and we take that to be time 0 when we start our interval. And we can see that the stone rises to a maximum height. A would be the maximum height reached, and that is at time E. After that, the stone falls downward, and we can see here it intersects B's graph. So clearly, that's when we stop our interval. That's when A and B meet at that certain height, which we know is 29,74 meters above the ground. In other words, 10,26 meters below the launch point of A and the dropping point of B. Let's look at B. B only moves downward from when it's dropped at time F, which we know is 1,34 seconds after the start of our interval, and it falls down until they meet at that height I've already referred to at time G, which is 2,79 seconds from the start. Let's now look a little more in detail at what's going on here. Let's speak about the gradient of each of the graphs at various points. Now we know that this is a position time graph, so its gradient is change in position, which is displacement, per period of time. And change in position per period of time, displacement per time, is velocity. So we can see things about the magnitude and the direction and the change of these, of velocity from the graph. So let's start off with graph A. We see that for this period here, 1, the velocity is positive. The gradient is sloping this way, positively. And we know that that is true because a positive velocity in this case, because we let upward be positive, means that the stone is moving upward. So for all this period of time, the stone is moving upward. And then we see that the gradient is 0 at that instant, meaning the velocity is 0. It stops for a moment. And after that, the gradient is negative. It's moving downward. Whereas for stone B, the gradient is always negative because it only moved downward. What about the magnitude of the gradient? Here we can see how it's getting less and less steep, meaning it's slowing down. And that makes sense because it's moving upward, even though it's accelerating downward. And when motion and acceleration's directions are opposite, the object gets slower and slower. So it slows from 10 meters per second to 0. And then the rest of the motion, we can see that the gradient gets steeper and steeper and steeper, as is also the case for B, steeper and steeper and steeper, which makes sense because for that part of the motion, the acceleration and the motion are both downward. When they are in the same direction as one another, then the velocity increases in magnitude. Gets steeper and steeper in this graph. So let's go to the questions. First question asks us a time point from these points that are given when the velocity of stone A was positive. Now we know it's this entire period, but the only point given a label to for that period is D. Don't say H, because H isn't a time, it's a position. Next question, the maximum height reached by stone A. That is A. Be careful, don't say E. E is the time at which it reached the maximum height, but A is the actual height. The time when stone B was dropped. F. Don't fall into the trap of saying it's B, that's the height, but F is the time. If we had to actually give a value, notice it would be 1,34 seconds. Finally, the height at which the two stones pass each other. C. Again, don't fall into the trap of saying it's G. And if we would have been asked to give actual values, C's height would have been 29,74. If we'd rather been asked to give the time, which we weren't, but if we had been, then it would have been 2,79 seconds. And before we go, have you already liked? Have you subscribed? Have you left me a comment? And please go and visit my website. You'll find a lot of resources there, and they're categorized in a way that will make it very easy for you to find what you need. Until we meet again, learn science!